All right, so here are the solutions to the free response questions I gave you guys on Monday. Again, number 3, we could use a calculator. Like I've mentioned before, the free response questions you're going to be given next week. You don't need a calculator, although you'll be able to use one. All right, so taking a look at number 3 here, we're given a function t of h, where t is a temperature in degrees Fahrenheit and h is the number of hours from midnight, and the number of hours is between 0 and 24. So for part A, the initial temperature at midnight was negative 15 degrees Fahrenheit, and at noon of New Year's Day was 5 degrees Fahrenheit. We just need to find A and B. So there's no calculus involved. All we're using is this function twice, though, given these two situations. So I'm just writing this out, that t of 0 is equal to negative 15 degrees Fahrenheit, and simultaneously over here, t of 12 is equal to 5 degrees. So I set my t of h, t of 0 actually equal to negative 15, which means 0 is going to go in for h, and then over here, t of 12 is equal to 5, so 12 goes in for h. And then I continue to simplify both of these, and what I'm creating here is a system of equations. We saw this a lot for like our population or exponential growth type problems. So here we are getting cosine of 0, which is just 1, so I get negative 15 is equal to negative a minus b. On the other side, 12 pi over 12 will just give me pi. Cosine of pi is negative 1, so that turns it into a plus b. And then I set this up as a system of equations to find a and b. So a turns out to be 5. You can go back up into either one to find b, which was 10. All right, question B was asking us to find the average temperature for the first 10 hours. Well, the temperature is the y value because temperature is dependent on the time that passes. So this is just a good practice problem of average value. And then here's the formula for average value, in this case of the first 10 hours. So I'm going to set this as 1 over 10 minus 0 times the integral from 0 to 10 of our t of h function. And all we have to do is type this into the calculator, and we get approximately negative 6.910 degrees Fahrenheit. All right, for question C, we were asked to use the trapezoidal rule with 4 equal subdivisions to estimate the integral from 6 to 8. So in order to do that, to divide this up into 4 equal subintervals, each difference or change in x is just going to be a half. So to set this up, the trapezoidal rule tells us we're going to take 1/2 times our height, in this case the width of each distance between the x values here. And then as long as we're talking about equal subintervals, this is where we take our first, remember this was like the y naught here, and then plus 2 times y1 plus 2 times y2 and so on until we get to that nth value here. So I wrote this in as t of 6 plus 2 times t of 6.5 all the way up to the very end here, and then we just have a single t of 8. Now to make this easier to type on the calculator, I just define t of h right here. And that way it allowed me just to type this whole thing in. So this is just 1/2 times 1/2 times, and then I had to hit the variable key, t of 6 plus 2 times t of 6.5. So in doing that, I'm getting negative 4.890. And now for D, we had to find an expression for the rate that the temperature is changing with respect to h. So this is just to take the derivative of t of h. Now normally we're used to doing this with dh over dt. Well, in this case, h is the hours, so that is the time. And all we have to do is take the derivative. We really don't need a calculator for this. The negative 5 just turns into a 0, and then the derivative of the second part using the chain rule, we get negative 10 times sine. The inside stuff stays the same, and then it's times the derivative of the inside stuff. And then just simplifying this, we get negative 5 pi over 6 times sine of pi h over 12. All right, now number 4, this is a good related rates problem. And what's nice about this is that parts A and B together kind of make up that whole 6-step plan that we went over way back when in class. So for A, it says find an expression for the volume of water in the tank, and it's a conical tank, in terms of its radius at the surface of the water. So this is really telling us to draw our picture, and then kind of like steps 1 and 4, you figure out the equation that we're using. Now in this case, they don't give us the formula for volume of a cone, so I have it written out right here along with our picture. And we want to get this in terms of radius only. Well, since volume is equal to 1/3 pi r squared times h, I need to replace the h with something in terms of r. So this is where our picture helps out. So this is where we're going to set up a proportion, because it's like we have a smaller cone within the larger cone. So in doing that, I just say that r over 20 is equal to h over 60. Solve for h in terms of r, cross multiply, so I get 60r over 20 which is going to equal 3r. So I replace the h up here with the 3r, simplify, and then part A is done here, so v of r is just equal to pi r cubed. Now for B, this is where we actually figure out a related rates here. And because it's saying at what rate is the radius of the water in the tank shrinking, that means it's decreasing. Now normally we would see a negative sign with it, but if we use the word that it's either decreasing or shrinking, we don't need to put the negative sign there. So I'm not going to use any negative signs with the values here. But I do want to show you again that dV over dt was given in the first part of the problem, 48 pi cubic feet per minute. We want to find dr over dt when r is equal to 16 feet. So I'm going to go back to the problem we got, or the answer we got in part A. Tell me this froze up again. All right, give me 1 second. All right, so I use the formula for that we got in part A, and I just take the derivative of each side, but keep in mind this is now going to become 3 pi r squared times dr over dt. And then when r is 16, I simply substitute this in, and then the 48 for dV over dt. Now I just left everything, since this is a no calculator problem, I didn't actually square the 16 and multiply it by 3 because I know there's common factors. So the pi's divide out right away, and then if you take a look at the top right here, just we could cross out 16 goes into 48 3 times, and then this 3 divides out with this 3, so we could get to it a lot easier than making the larger numbers. So again, because I'm using the word shrinking, we're going to say the radius of the water in the tank is shrinking at a rate of 1/16 feet or foot per minute. If we didn't use that, we would have a negative sign. If we were just saying it was changing, we would want to indicate the negative sign to show that it was decreasing there. All right, and then question C. How fast is the height of the water in the tank dropping at the instant the radius is 16 feet? So this has nothing to do with volume. This is simply asking how is h related to r. So we found that in part A, that h was just equal to 3r. And we know when r is 16, we just found that dr over dt is at 1/16 foot per minute. So all we have to do is, I know how to work the screen here. H is equal to 3r. dH over dt is equal to 3 times dr over dt, so it's just 3 times 1/16 or 3/16 feet per minute. All right, so these were the solutions to these two free response questions. As always, guys, please let me know if you have any other questions about them.